In this video, we are going to go over indices and powers. Now, in this video, we're going to learn how to find the value of x if you have been given 25 to the power x equal to 5. How do you come up with the value of x, and also maybe how to evaluate 5 to the power 3 multiplied by 5 to the power negative 1 multiplied by, let's say you have 81 to the power 0. How do you solve such an expression? And also maybe you have been given, let's say you have 27 to the power, let's say you have 2 over a 3. How do you handle such questions? So in this video we are going to learn how to uh, manipulate these equations or evaluations. Now, uh, if you are really interested to be seeing this kind of videos, feel free to join our WhatsApp group through the link in the description. If not, you might just do well by subscribing to the channel and also to like the video so that whenever we post a new video, you'll be notified. Now, without wasting much of your time, let's dive into the topic. Now, the way indices operates is more like it's a simplified version of expansion. So for example, if you have been given, let's say if you have been given 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, so which simply means that 3 it's multiplying itself how many times? 1 2 3 4 5. Now how can we represent this? This can be represented by 3 to the power 5, where 5 it is the power, or we can just call it as the index, where at the 3 it is a base. So this is our simplified way on how we can write 3 to the power 5, more like in order for us not to get more space. So basically that's the idea of indices. Now, one thing which you have to understand again is that any number which can be represented by p raised to the power n can be any power except a 0 going up there, and also most of the times we end at 10. So except from 0, any number in between, and then we reach at what? At 10. This can go as in p multiplied by p multiplied by until you reach the value of n. So in this case, if the value of n was 6, therefore we can just say p to the power 6. We're going to multiply how many times? P is going to multiply 6 times. You're just going to be multiplying p multiplied by p. So you have 1 2 3 4 5 6. So which simply means that p has multiplied itself how many times? 6 times. So basically that's what you have to know. Now let's observe this pattern. Let's observe this pattern. For example, you might have let's say you have 3 multiplied by 3 multiplied by 3. This is equals to what? 3 to the power, how many 3's do we have? 1 2 3. So this will be raised to the power 3. And then what if you have 3 multiplied by 3? How many 3 do we have? We have 2. So we have 3 raised to the power 2. And then if 3 is raised to the power 1, this is just how many 3's do we have? We only have 1 3. So that's how the pattern goes. Now you have to understand that these indices have rules. The rules of indices are as follows. So you might have, let's say the rule number 1, you might have p. Let's say p is any number raised to the power 0. This is equals to a 1. So any number or letter raised to the power 0, it is equals to a 1. For example, let's say you have 256 raised to the power 0. This is equals to what? A 1. Let's say you also have, let's say we have 28 raised to the power 0. This is also equal to what? A 1 there. So any number or letter raised to the power 0 is equals to a 1. Let's say we have 81 over 20 raised to the power 0. This is also equal to a 1. If we have let's say we have b over x, as long as this has been raised to the power 0, it is equals to what? A 1 there. So that is the first law of indices which you must know. The second one, is, let's say you have p to the power 1. This is equals to what? This is equals to p. So any number raised to the power 1 is the number itself. Let's say you have also 30 raised to the power 1. This is just equals to 30. And also let's say you have 50 raised to the power 1. This is also equal to what? To 50, as in the number itself. And then the other one, is if you have p, let's say p multiplied p to the power m multiplied by p to the power n. This, as you can see, the bases are the what? Are the same. Therefore, you just get one base, and then the powers. What do you do with the powers? You add them. So you say m plus n. In this case, if you have 7 to the power 3 multiplied by 7 to the power 2, what do? You add the powers, and then you maintain the base. So in this case, you're going to have 7 to the power 3 plus a 2 there, which will be equal to 7 to the power 5. So that is the law of indices. Now sometimes you might be given let's say you have 4 to the power 1 multiplied by 4 to the power 1. This will be equal to maintain the base, and then you have 1 plus a 1. This will be equal to what? 4 to the power 2. So that's one thing you also need to understand. Another thing is you have to understand that, which can be a number 4. If you have let's say p to the power m over p to the power n, this, if you are dividing the bases, if the bases are the same, what do you do with the powers? You subtract, and then the one which is on top, it is the one which is going to go first. So you are going to have p to the power m minus an n. So this, you maintain the base, and then what do you do with the powers? You subtract them by beginning with what? M minus the one which is down there. So let's say we have 7 over 7. This 7 is raised to the power 4, and then this is raised to the power 2. This can be represented by you maintain the base, and then what do you do with the powers? You subtract them. So it will be 4 minus a 2 there, which will be equal to what? 7 to the power what? To the power 2, like that. So that's how you go about indices. And also another rule is, if you have let's say you have been given pm in brackets, and then outside there's an n. As you can see, an n, it is the power, and an m, it is the what? It is the power as well. So an example of this can be, you can just say, for example, if you have 3 to the power 2, and then outside you have a 3 there. So if the powers are like this, there's multiplication there. So this can be represented by 3 to the power, and then you multiply 2 multiplied by 3, it is what? It is 6, like that. So that's how you manipulate this. And then if you have been given, let's say you have let me wrap this. Let's say you have been given pq, let me just say pq to the power n in the brackets. This represents p to the power n, and then q to the power n. It's more like you're just distributing what? Distributing n to the bases that you have inside. So the last one which I can give you, which we call it, let's say we call it 7, we can represent it by having let's say we have 1 to the power n is equals to 1. where n it is any number. N it is what? Any number. So if 1 it was raised to the power, let's say 100, the answer will be still what? A 1, because 1 multiplied by 1 up to 100, you are going to just to get a what? A 1. If 1 is multiplied by, let's say, 1 raised to the power 25, the answer still is going to be a what? A 1 there. So those are the laws of indices. Now, understanding these laws, if you have understood these laws, let's uh, let's try to solve this question. Let's try to solve 5 to the power 3 multiplied by 5 to the power negative 1 multiplied by, let's say you have 18 to the power 0. So how can you solve this one? Remember, one thing which you have to do is to remember the rows. So here we have 18 to the power 0, which simply means that any number raised to the power 0 is what? A 1. So we have sorted this one. So we know that here we're going to have a what? A 1. Now here, as you can see, the bases are the what? Are the same, and then you are doing what? You are multiplying. What do you do with the powers? You add them. So you are going to maintain the base, which is a 5, and then you say 3 plus. Now here it is a negative 1. You put it in the brackets, and then here there's multiplication, and then you have what? 18 to the power 0, and then 18 to the power 0, any number to the power 0, it's a 1. So when you have 5 raised to the power now 3 plus negative 1 is just a 2 there. Now multiplied by a 1, this will be equal to what? Now 5 to the power 2, we know that you have how many? 5. We have 2 5, so it will be 5 multiplied by a 5, which is equals to what? 25, like that. So that is your answer there in this case. Now, having understood this, try to solve this example. Let's say we have 3 to the power, let's say we have a 4 there, multiplied by 3 to the power 2, multiplied by 3 to the power negative 1, multiplied by, let's say you have 9 to the power 0. What is your answer? And also try to evaluate. Let's say you have been given 9 to the power 0 multiplied by 9 to the power 3 multiplied by 9 to the power negative 1. What is your answer? Try to go through this, and then you see what you can find, and then your answer you can comment in the comment section. Now I just wanted to talk about let's try to discuss a little bit about the roots. Let's try to talk about the roots. So the nth root of any number, let's say we have p, is denoted by n as the root to the power p, where n, it can be any number, any number, and also p can be what? Any number. So an example, if we say we have let's say we have n, let's say n is equals to 2, which simply means that you are going to have the root of p. But here the root of 2, we don't show it itself. The root itself is just showing that no, we are having a square root there. And one thing which you have to understand again is that the root of this number, let's say it is in a 9 there, this it is also can be represented by 9 to the power 1 over n, where n becomes the root and then 1 becomes the power of everything. Now let's say we have the square root of 9 raised to the power a 3. This is equals to what? Now the root of 9, it is what? A 3. We know that when we say 3 multiplied by 3 is going to give us a what? A 9. So how many 3's do we have? We have 1 and 2. So we have a 3. Now this 3 is raised to the power what? To the power 3. Therefore we have to expand this. You have 3 multiplied by 3 multiplied by a 3 there. Now when 3 multiplied by 3, it is 9. 9 multiplied by 3, it is what? It is 27. So that can be your answer. So I hope we have understood this as well, because it is very important. Now let's say we have this number. Let's say we have 8 to the power 1 over a 3. We understand that this is equals to what? This 3 becomes the what? The cube root, as in like that, the cube root of 8, and then the 1 on top, it becomes the what? The power of everything. And then this, the cube root of 8, it is what? A 2 raised to the power 1, and then this, we understand that it is equals to what? A 2. Now this simply means that we are going to have, this is also true, that a 2 there is multiplied by how many times? 3 times. So we say 2 multiplied by 2, if it is a 4, and then 4 multiplied by 2, it is what? It is 8, like that. So basically this is just an explanation which you guys have to understand. Now having understand this, I hope you have understood this. I mean, let's try to solve this question. You have been given, let's say you have been given that, no, given that 4 to the power negative 2 is the reciprocal of what? 4 to the power n. Let's find the value of what? Of n. So how do you find the value of n? They have said that 4 to the power negative 2 is the reciprocal of n. What do they mean when they say a reciprocal? A reciprocal, it is represented by, let's say we have 4 to the power n. This is equals to, now the reciprocal, just the opposite. Now the opposite, it is what? 1 over 4 to the power negative 2. That's how you come up with the reciprocal. So let's say we have a, the reciprocal of a, it is 1 over a. Now the reciprocal of b, it is just 1 over a b. Now the reciprocal of 2 is represented by 1 over a 2. That is the reciprocal. Now having understood this, let's solve the question. So we have been given that, no, the 4 to the power n is equals to, now 4 to the power n, it is the reciprocal of 4 to the power negative 2, like that. So how do you solve this? This, you start by simplifying whatever you see is complicated. Now as you can see, this 1 over, this over just simply means that there's a division there. So you put the division sign. They are going to have what? 4 to the power negative 2, like that. So if you have 4 to the power negative 2, therefore you're going to have 4 to the power n is equals to, now 1. You and I agree that this 4 to the power negative 2, it is also the reciprocal of 4 to the power negative 2 is also the reciprocal of 1 over 4 to the power 2. So this will be represented by 1 over what? 4 to the power 2. The negative has become the what? The reciprocal. So this 4 to the power n is equals to, now here you understand that in order for us to introduce multiplication, the denominator becomes the what? The numerator, over the numerator becomes the denominator. So 4 to the power n, this will be equal to what? 1 multiplied by 4 to the power n, it is just 4 to the power n. As you can see, the bases are the same, so you cancel the bases and then you are going to remain with what? N is equals to 2, like that. So that is your answer. Now I'm going to leave you with these practice questions which you have to go through on your own time. So the first one which I can give you is, let's say you have 25x is 25 to the power x is equals to 5. This is very simple, you just have to make the bases to be the same. And also let's say we have the fourth root of 81 raised to the power 3. You can comment your answers as well. And also let's say you have 27 to the power 2 over a 3. Remember, if you have been given b to the power 1 over a 2, this can be represented as the root of b raised to the power 1. Thank you for your time.